Hello, folks. Sorry, being late. Hello. Let's wait a couple of minutes. See if the number is stabilized. 18. All right, one more minute. In the meantime, if you want to sign up on the document that is in the chat.
Only in the chat for people who arrived on time.
Sorry, Hank, what? So for the people who?
Only available for people that arrived on time, because Zoom chat doesn't
Okay.
contain messages
Oh,
about it.
right, I am reposting it. Thank you for the heads up.
The link is also in the invite for anybody who is looking for more permalink here.
Awesome, Hank. Thanks again. All right, I think we can start. And today, what we have in the agenda, we have Jonuts, who's gonna present a report from ATF 123 about attested TLS in the context of the attested TLS project that we are running under the CCC-SIG umbrella. So, Jonas, you want to take it from here?
Yeah, sure. Let me just share the screen.
Yeah. How do you want to take questions in line?
So whenever someone has a question, but yeah, I probably won't be able to see hands up or anything like that. So do stop me.
Yeah. I will monitor the participant list.
Cool. Yeah, let me know if you can see the screen.
Yep, that's great.
Cool. So just to give a bit of context, so this is remote attestation and integration in TLS is one of the projects that was adopted, sub-project that was adopted by the attestation SIG. And this is separate from the formal verification project that Usama has been giving updates on. So some of the things I'll be discussing here will be basically similar, but just wanted to bring you an update from the implementation and standardization side of things, just to keep you informed since I don't think we did give this update last year, so yeah. Oh, Usama.
So, just to clarify, I think if I remember correctly, so the SIG project that you mentioned by itself contained formal verification as part of it. So it's not a separate project, so to say. So the proposal that was in the GitHub, so that was accepted. The formal verification was a part itself of the project and not a separate project, so to say.
I think we have it as a separate project formally. Then, of course, they all, bunch together quite nicely. So we tend to consider them in a clump. But if you go to the CCC attestation repo on GitHub, you'll see them listed as separate.
Right, but I mean they are separate separate things. So one was for trusted execution environments, which we have completed. The other one was for KBS. They are, of course, like both separate projects. But the one that we are talking about here is in the GitHub issue. If you see, there was some discussion, and the formal analysis was a part itself of the issue that was. I can put a link in the chat, but I just wanted to clarify that that was that was not a separate project itself. So formal analysis was a part of this specific project.
Okay, sure.
Well, whatever, but
Yeah.
the POC is a different thing. Anyway, it doesn't matter because effectively what happens is that we're really running them as a coordinated lump. So, okay, go ahead.
Cool. Yeah. Yeah, so I'll be focusing mostly on the standardization and implementation side. So just wanted to tackle first the question of why test the TLS and why we chose to go with this project and adopt it in the first place. So obviously, remote attestation is great in terms of offering us a tool to understand the security state of some workload or some device, but it cannot really be used on its own to secure communication channels with said workload or device. And on the other hand, you have secure channels that, or secure channel establishment protocols that can bootstrap connections to, let's say, a known network identity. But we can't really use those at the moment to probe the state of the device, or we can't integrate the probing within the channel establishment, basically. So the reason for this project was that we wanted to integrate the two. So we wanted to know the state of our secure channel peer when we establish that channel, and to be able to make that trust decision with more context. Since the TLS handshake is probably the most used secure channel establishment protocol, it was the prime target for us, prime target for enablement. So that's what we started with. If we take a brief look at how the TLS handshake looks like, I try to color code it here, but basically you have two peers, client and a server, and they exchange a bunch of messages. The exact contents of all of these messages is not strictly relevant here, but I try to mark out the extension points in blue. And you can see that both sides send extensions as part of their hello message and also as part of the certificate message. The extensions sent in the server and client hello are generally used for things like negotiation of parameters, and the ones in the certificate message are mostly related to authentication. And these will, the importance of these will be apparent shortly. But yes, basically we're trying to integrate or to somehow extend remote attestation using these extension points and make sure that TLS handshake can also present the security state of the peer, as well as the things like certificates, PKI certificates, or whatever traditional mechanisms for authentication it uses. So in terms of our goals, we had a few to basically guide our way. And also we had a bunch of non-goals, but I'll start with the goals. So first one is to follow established best practices. And that means in this context, for example, things like negotiating the features and the parameters that will be used throughout the handshake and for a respective session. So this might mean things like whatever cryptographic primitives are used for the TLS session, but also in our case, whether remote attestation will be used, maybe conveying anons, stuff like that. We also want to make sure that we do a secure integration between the the TLS handshake or the TLS session and remote attestation session, basically. We also want to enable as many topologies as possible. So we want to enable both background check and passport model if possible. We want to allow both client and server to attest potentially mutually. And on top of it all, we want to not modify the core TLS protocol. And this is a newer requirement that I'll get to later. But this is basically why those predefined extension points were highlighted previously, because that's what we have to work with if we want to do the integration. On the non-goal side, we have a few rules again to guide us into things that we don't want to achieve, basically. So we don't want to create any new remote attestation primitives or API. So we don't want to define ways for, let's say, the relying party and the verifier to talk. We don't want to define new, let's say, attestation evidence formats or APIs to talk at the backend. We're just interested in defining this integration between TLS and remote attestation. We're also not interested, or we don't want to guide our design towards web use cases. And this is primarily because remote attestation has been a touchy subject since the IAB has issued its statement about integrating remote attestation into protocols and how it might lead to problems both regarding privacy and also, well, fragmenting or limiting the web space, basically. And we also don't intend it to be a universal solution. We're not saying that TLS will have to be the way everyone does secure channel establishment or the only protocol that needs to be integrated or has to be integrated with remote attestation. This is just something that we thought would be useful since so many applications use TLS, but we don't want it, or don't want to give the idea that that we think this will be the ultimate solution for all secure channels for use of remote attestation. Okay, so with the goals established, what exactly are the properties that we're looking for as part of this integration? So first of all, we want, as I mentioned before, we want to negotiate remote attestation parameters. So we want, for example, that both the TLS client and server to be able to signal willingness to engage in the remote attestation, and not just assume that the other end would be able to do that or not do that. On top of that, we want to the relying party or the verifier, I guess, to be able to convey a nonce to the tester. And not written here, but also important would be to for us to potentially allow negotiation of formats or other parameters that might be relevant in the future. We also care about freshness of attestation evidence. So if background check is being used, then it should be possible to prove the freshness of this evidence, for example, via a nonce, to prevent any attacks that might leverage on stale evidence. Since we care about that freshness, obviously, and since remote attestation can track runtime state changes of the workload or of the device. So for example, all the platforms have, existing platforms have extensible measurements that a workload can essentially measure into at runtime, or with the use of things like VTPMs, like was described in the last two sessions of by Microsoft. So since we have those primitives, we should be able to check credentials repeatedly in a way that's not a performance bottleneck, and it doesn't require well, heavy lifting changes to the session. And last but not least, for sure, we need to have a strong cryptographic binding between TLS and remote attestation. So there must be some way to verify that the endpoint that we're trying to talk to in terms of the network identity is the same entity that's represented by the attestation credential. Because at the end of the day, if you can't trust that, then the binding and the use of remote attestation is basically useless. Yeah, Eve.
On the freshness bullet here, I don't think this is probably like critical to like the rest of the presentation or to the standard in general, but I made this comment before, but the freshness property is not exclusive to background check. You can still do this with Passport, and I just want to make sure that we don't preclude that anywhere from any of the language or mechanics. Is that, do you agree with that, or is that a
I think I agree. I'm not sure I've looked at cases where Passport would somehow reflect that noise, but I mean I can imagine the mechanisms for which this would happen. Yeah,
I mean,
okay, sure,
I think
makes sense.
it's largely thought of like the Passport being equivalent to like a TLS certificate, which isn't always the case. It could just be
Okay.
a like OIDC token with attestation results or something like that. So.
Okay, yeah, makes sense. Okay, sure, that makes sense. Thanks. Greg?
Yeah, thanks. How does this work? Think about like existing TLS keys that are like used in web farm kind of scenarios, right? So, and what I'm kind of fishing for is you're trying to establish trust with the secure communication channel that's secured by a TLS key. And how do you know that the attestation evidence that's been shared by the relying party reflects the totality of all the code, or the entire environment that has access essentially to the key that's used to secure the channel, right? So it's how do you ensure that you're evaluating that you're evaluating all the code that potentially has access to it, not just this particular endpoint. Maybe this is a key that gets shared across lots of front ends, and different front ends have different TE environments, or perhaps no TE environment. And does this think about that problem at all, or is that just kind of out of bounds?
Well, I think it's somewhat relevant. So obviously the way the remote attestation measurements reflect basically what
I think it's really about the management of that key. So it's one thing to say that this TLS key is cryptographically bound to this particular set of attestation evidence that shows that those two things have are linked and have seen each other, or the remotely attested environment has seen that particular TLS key. But how do you know that's that's a complete set of everything that's seen that key? Because that's what's then trusted ultimately, is that TLS key.
Well, I think the TLS key is trusted in terms of obviously signing the certificate verify message.
Yeah, but when I'm doing a secure channel, right, I'm saying, okay, if I'm going to bother to look at the attestation evidence, to say, well, if I'm going to bother to look at the attestation evidence for something that's cryptographically bound to this TLS channel, I'm doing it because I'm trying to ensure that what's on the other side is something I trust. And the encryption of the channel is some key, right? So I need to I need to understand something for that trust decision. I need to understand the not just an instant snapshot of, oh, this particular TEE measured TE environment, has visibility into that key. But I need to understand like what system manages that key and what's the policy by which it may share, with other environments, right?
But Greg, there's more to it than that, right? I think you're breaching into the realm of what is the intent of the like attested party is off. So like, what am I even speaking to? Like, it's just an attested CVM is one thing, but what is it allowed to host? What do I trust it for? And so that seems to breach into policy decisions that we need to be aware of. True, like yes, we need to be aware of it, but there's more to it than just like who has seen this key. It's also like what application is it running and what do I want?
I think you may be right, but I think the most simplest way I can think of this is if I establish a measured, an attested TLS channel, and ultimately that channel is cryptographically secured by some key. I'm actually trusting, to know that I'm trusting any party that can sit behind that has access to that key and can sit on the network and route traffic to and from wherever I am on the network.
But isn't that a discussion? So I'm not sure we're talking about the same key, because there are two keys here, right? So one key that's used to sign the TLS handshake, and then one key to encrypt and decrypt the traffic. Well, multiple keys, but basically one master key. The key that signs the handshake, I guess the T could have access to that through some sort of API, or you might not have transparency into everyone who has access to that, but you'd be able to see from the measurements at least what kind of, like how the stack gets access to that. I'm not sure I understand your question.
I think I understand. And I think the answer, or an answer, is that this is, as Fritz said before, basically a policy decision on the relying party side, right? So either the relying party as a verifier or the verifier itself that is paired with the relying party. What we can. So it doesn't really belong in the protocol part here that you are describing and we are trying to formalize, but it is a set of requirements that needs to be clear, right? Clearly made to the relying party. The relying party, you need to check this, and that, right? So whatever evidence will
and it has to be checkable, right? So
yes. Properties needs to be. This T has to have exclusive access to the key. The key must not be exportable from the T, etc., etc., etc. Right. So there's a set of things.
It can be if that's not a promise given, right? Like if part of the promise is like, look, I only share my key with other of these TEs, and I'm running like Apache, whatever, that can be a promise that is like different to whatever T, different to whatever entity you talk to, right? So it's application specific, I would say. If it's a promise given, yeah, it's part of the tested code.
The problem is that once the key leaks outside the T, then right. So
yeah, then the promise is bad, but it's still a promise given.
So, and I'm admittedly, I'm not connected to all the details of what's going on here, but I'm just thinking like an existing, website, www.amazon.com, and there's some key, there's some key that represents that TLS endpoint, and I trust it to do my shopping, but that's clearly not running just in one particular environment. That's running, it's for scalability purposes, lots of places. So I have a particular connection to a particular endpoint, and it's giving me some particular attestation evidence. That's local, but the trust to basically say this is Amazon has to come from somewhere else, right? So how do I know, that, okay, I know I'm talking to Amazon, and I know that Amazon, even though I'm talking to this endpoint in Amazon, and it's proving that it's running inside of, this particular TEE, but I need to know for my decision purposes whether what I'm gonna put on this channel is, well, what's all the different ways that, this key, which I think of as Amazon, somehow that has to happen. I don't think that's the attestation evidence. I think that's coming from some.
That's part of the authentication side, right? So this is the key that authenticates the handshake, that is certified by someone that binds that key to an Amazon entity.
So maybe I should just be quiet and kind of listen to all the details. But that's I don't understand how I could make a complete trust decision in such kind of an environment where, but I just may need to just kind of listen to all the details and read all the documents, and maybe there's an answer.
Okay. Usama?
Greg, I really like your point. I think you are thinking exactly on the lines what I have been thinking on. That is, let's say I have Amazon.com. I want to connect to Amazon.com. And how do we actually ensure that actually I connect to Amazon.com and I have the right measurements of that piece of software stack that it is running? So I think that's exactly that's exactly the kind of guarantee that at least I, in my mind, have been thinking of kind of using this technology, that I do authentication. So the first part that is that I'm connecting to Amazon.com is authentication rather than attestation. And the second part, which is that it has the software stack, it has the right measurement, which not the right measurement, I mean, there could be something buggy as well, but it has the expected measurements. So the second guarantee is coming from attestation. And the way I think of it is that both have to be provided to you as a user in order to make a decision that you are connecting to Amazon.com and the software stack underneath is the right one, and the hardware underneath is using a confidential computing platform. So I completely agree with you. So whatever you said makes perfect sense to me. And to elaborate a little bit on losing the attestation, the TLS key, I think was one of the points that you mentioned, and I think that will break all guarantees in this case. Namely, I think Jonat was trying to distinguish between the application traffic keys for TLS and the key used to establish the connection. That is the one which is used to generate all of that. But I think both are related. I mean, in the TLS key schedule, if you lose the key, you lose GXY, and then you lose the whole stack, like all the application keys will be then available to the adversary. So kind of a short summary here is that in my mind, we need both attestation and authentication in order to ensure that the stack is correct, the hardware underneath is correct, and the entity you are connecting to, Amazon.com, is also the one actually authenticated via WebPKI. Does that make sense to you, Greg?
Yeah, I'm just kind of thinking about it a bit more. It's like to make the trust decision, like the first part of before remote attestation is involved, the first part of trust is looking like typically at the subject name in the TLS cert. Say, oh, this is www.amazon.com. Okay,
Right.
cool, I trust it. Now that I get to looking at attestation evidence, it says for this particular endpoint, which is in one of their machines in their data center, this is what I know. It's this TEE, blah, 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 and this is securing the environment. But I'm about to give like my credit card information. I know nothing about all the other, places in Amazon that, basically have access to the key for that TLS certificate with that subject name, which, may influence my decision, right? Whether I want to provide my credit card up there. Because in a future TLS connection, it may go through a non-TE thing where it's also dealing with my credit card. That's my best.
But the whole point of this cryptographic binding is that if you can check and if you can understand the evidence that's provided, and you can check essentially what the TLS stack does and what kind of application sits behind it, then because of this cryptographic binding that particular stack with that running application is the one that you're connecting to, and that guarantee would essentially even if the key is lost, you still have the guarantee.
It's
Jonat,
what I can't. Well, I understand that this is through attestation evidence is cryptographically securing a particular connection. And for that, it's telling me something. It's giving me some assurances. And there are TLS connections that are, they TLS connections to an endpoint typically start with a DNS name, and you go there and you form that connection, and over time, different connections may get to different environments, which may have different properties. And when I think about it, and I kind of can understand the perspective of, saying, well, that's, for what we're doing here, this is about securing a particular connection. And I think what I'm just thinking through is that how valuable is securing, and I don't know the answer, but how valuable is securing an individual connection to something I think of as one thing, like Amazon, if if the details of the security on the other side kind of are different every time I connect. I probably on my side want some policy that says, whatever's on the other side, whenever I connect, the min bar for me is X, Y, and Z. It always has to be a TEE or something. And it always has to be, and I understand it's kind of out of scope, I think, of this looking at a particular connection, but how applicable this is, and how widely adopted it might get may be influenced by kind of the larger picture. And
Greg, as you said, it really depends on your policy, definitely. So the wider the policy, the wider the net that you're casting, the more usable it is, and maybe the less secure it is. So there's always a balance right here too. But Ariel has the hands raised since forever, so I think I want to give him some time.
Yeah, I mean, I just wanted to I'm not sure that this actually is a distinction that matters, but there may be a small distinction. There may be a distinction here where, in some sense, there are two signing keys. There's one that is sort of owned by the, that is the sort of the traditional TLS leaf certificate that, deals with the binding of the identity, like Amazon.com in this example. And there's another signing key which sort of belongs to the trusted execution environment and presumably never leaves the trusted execution environment as kind of the anchor for the sort of attestation portion of the authentication of the connection. And I'm wondering whether, Greg, you're getting at the idea that we have some idea of the provenance of the signing key for the attestation portion, but we don't really have an understanding of the provenance of the signing key for the traditional TLS certificate. And you might say, well, maybe that doesn't matter because you're adding on this additional attestation key. But would it be a useful property that the leaf certificate used to bind the identity, like Amazon.com, actually something about its provenance, it was its private key was generated in a particular TE, and maybe you could sort of, by some chain of reasoning, understand that maybe it never left a TE, because that kind of relates to one of the ways of doing this, because I remember seeing previous presentations about this where, there are questions like, should you do post-handshake? Should you do pre-handshake? And if, pre-handshake would be actually sort of baking the attestation in the TLS certificate itself, like RATLS. And I'm wondering whether there are definitely advantages to doing it post-handshake, but I'm wondering if one thing you might get if you do it pre-handshake is this binding, is this sort of provenance information about the identity key, like the regular leaf certificate. I'm not sure that this is true, but I'm curious.
In the service I work in, which has a signing key, it signs attestation result tokens, but we make sure that the provenance, essentially that signing key, which is replicated across multiple machines for scalability purposes, we make sure that cryptographically through attestation evidence, that key, not a session key for an individual session, but the individual TLS session, but the signing key used for a token, whichever attested environment it comes from, whichever attested virtual machine it comes from, the code base that basically has access to that key in the in the clear is measured and captured in attestation evidence. So it's yeah. Sorry. Go on. Yeah, I'm paused. So I've got to think some more.
I
Okay.
think maybe I can add a few words
Well,
on
we
the
are
lines of.
we're a bit tight here. Jonas,
Okay. Okay,
how
sure.
deep are you in the presentation? Because it seems like
About roughly halfway through if we just look at the number of slides, but yeah.
let's move on a bit, and then maybe
Okay,
Usama,
sure.
you can get back to the floor.
Okay, cool. Okay, so if we move on, I think it's already been mentioned, but basically the design space we were looking at, and I think this is something that Usama presented and included multiple times, is that we have basically three options regarding where the actual signing of claims to generate a remote attestation credential would take place. So this can take place before the TLS handshake, which we call pre-handshake, during the TLS handshake, which would be interim, and then after TLS handshake, and that will be post-handshake attestation. And so this is the space, and if we look at existing solutions out there, options that have been either deployed or at least put down as specs, we have quite a few options in all of these categories. So clearly there's some fragmentation, and obviously each of these options has its own set of properties and its own set of correlations with the different properties that I mentioned before in terms of freshness, refresher of credentials, all those things. But yeah, I wanted to present this mostly to make the point that it'd be good to have some standardized property, standardized options that people can rely on, that fulfill the properties that we were looking at. In terms of our current direction, so we started initially with an intra handshake proposal, basically putting the attestation credential in the certificate message, and also the negotiation. So everything would happen during the TLS handshake. But because of pushback from the TLS working group in the IETF, and because of higher risk of interference with them, we've moved on to a post-handshake solution, which also gives us some better options in terms of refreshing credentials. So our current solution uses exported authenticators. So this is a mechanism of, well, a framework that allows additional authenticators following a TLS handshake. So once you've established a TLS session, you can generate this authenticator request and send it over, and then the peer has to send an authenticator back. And using this framework, we can essentially introduce the remote attestation credentials. One of the properties of this is that the responsibility of fulfilling this this integration will now fall onto application layer to manage the whole request flow. But yeah, as I said, it better fulfills some of our properties. For example, it's easier to do repeated authenticator requests if we want to refresh the credentials, but otherwise we can still do binding of the TLS session to the remote attestation credentials. Gary?
Yeah, thanks so far for this presentation. I had a question on the choice of using the exported authenticators draft. If you go back to, there was a effort called TLS token binding previously in the IETF, and it was an actual working group with specifications. It ended up being discontinued after the browser vendors dropped it. But one of the things they used was exported key material to bind the application session to the TLS connection. Why was that rejected in the case of remote attestation?
I think if I remember correctly, the export authenticators frameworks work better for us in terms of it was a framework that we could just plug ourselves into, and it gave us basically the binding that we needed.
Yeah, I kind of figured that there was something lacking in the exported key material approach. But I just don't know what it is. That's what I was asking. Yeah,
right.
Go ahead.
So the exporters only export, right? So they allow you to bind whatever you have with the underlying TLS handshake. But what exported authenticators gives you also is the actual wire format for exchanging request response for the extra authentication, which we hijack for doing the attestation, the array protocol, right? So is a layer on top of that. Export authenticators also uses exporters from the TLS key schedule. And so it binds you practically the same way that you have with the normal TLS exporters. But on top of that, it gives you also the framing for the messaging between the peers.
Okay. All right. Thanks, Thomas. Okay. That answered my question. Please move on.
Well, thanks, Thomas. Yeah, right. So as I was saying, and Thomas was also pointing out, so this would be certificate requests from the initiator, and then certificate verify and finished from the attester side. And yeah, these are basically the same as the TLS handshake messages, just containing slightly different bits and binding to whatever we need. We move on to the status of our work in the IETF. So we have 2 internet drafts, which I've mentioned already, and both are in, let's say, alpha status. We have one for intra-handshake attestation that is, well, I guess legacy for now, and now in the newer one, post-handshake attestation, which uses the exported authenticators we were talking about. So we had a long-running attempt to get the first one, and actually the second one as well, into the TLS working group to get them to adopt our work, but there wasn't really any appetite or interest in the functionality from their sides. In the Internet Architecture Board kind of made this even less likely given that that statement they had. So our effort did end up culminating in a Birds of a Feather session at IETF 123 in July, so a month ago. And we managed to successfully advocate for a new working group that will tackle this topic. We're still in the process of establishing the charter and then kicking things off. Hopefully this will move forward, and by IETF 124, which I think is in November, we're going to have our first meeting for the new working group. In terms of to-dos and things that are still outstanding, so obviously we need to kickstart this new IETF working group and set the direction based on all the experience that we've accumulated looking at this problem from multiple angles. We're trying to produce comprehensive documents that cover our design rationale and all the properties that we care about and use cases, and also obviously to continue with the formal analysis work and to fix any gaps that we might have in security. It would be also very good to have a prototype for this post-handshake flavor. And unfortunately, the engineering effort could be quite significant, but given that there are a few groups that have signaled that they might be interested in contributing to this, it might not be too bad. But yes, unfortunately, most TLS libraries don't really support the exported authenticators as far as I know. So this would have to be built on top of that. So yeah, last thing I wanted to leave you with is a call for engagement. So please, if you're interested in this, in using ATLS or giving us any feedback, or if you're interested in deploying this once the standard actually ships, please join us and join the new IETF working group. And yeah, we hope to see you there, basically. Yeah, I don't know if there are any other questions.
Well, first of all, thank you, Jonas, for the report, and this is awesome. I mean, this is an activity that we incubated here in the CCC SIG, and now seeing it as the IETF working group for them is really great, and kudos.
Yeah,
yeah,
great. Really happy to see this. Good progress. So you call out here that an impediment would be that popular TLS libraries don't support the functionality that you require. How big of an issue is this? Like, is it like practically no TLS libraries support it? A couple do, but they aren't commonly used. A couple of commonly used ones are, and a couple aren't. Like, how big of an issue are you seeing here?
I think when I checked, there wasn't really any. Well, if I remember correctly, there wasn't any library, any TLS library, and especially the bigger ones like OpenSSL or Boring SSL, Russell's, Go TLS stack, and I think none of them implement exporter authenticators. So that work would have to be done for whatever stack we target, basically.
And back to there's a follow on, and back to the question a bit ago on directly using the exported keying material instead of this framework that's built on top of it. How invasive would that be to what's being done here? Is that something that could be added as an option to increase adoption or to make adoption easier, or is it too big of a change, and the easier way would be to try to push for support for this feature? This seems like something that would be great to begin adopting, but if it we'd hesitant to like roll our own libraries in order to do so. Using off-the-shelf ones is much easier to explain to customers.
Yeah, of course, and yeah, actually, that I guess could be something to look into. But maybe that would also lead to more fragmentation. I guess it's difficult to balance exactly which things are more important or more productive. Obviously, implementing export authenticators is well, I wouldn't say one-time thing because it involves multiple libraries, right? So you'd have to implement it everywhere. But if it's then upstream, then given that it is something that's generic and not specific to attested TLS, and maybe it could have a future. I'm not sure exactly how difficult or how much of an inconvenience it would be for us to try to support both. I've not really thought about that. I don't know if Thomas has any feelings about how much of a departure that would be.
It's as Keith says, if we have it in the stacks, then it's awesome, and I think we should push for that. In terms of prototyping, I don't know whether just building an application layer library that builds on top of 5705 and then builds the exported authenticators in the library is. That might be a good thing too, right? Because then we would have one single library that builds on top that basically parasites all the existing stacks for just the exported key material, which is an API that is implemented everywhere, right? That is something that is universally available in every stack. So maybe we should look at building library code for doing 9261 only. but then you have multi-language, right? So you can't just do it in C or in Go. You need to do Rust, you need to do Java, you need to do whatever. So I think the lower we can push the functionality, the better it is. And then you have binding. But that's we need someone to take ownership of that for existing stacks. So maybe we could look at embed TLS, we could look at the Go stack, but then boring, we don't know. Open, no. So it's something as Jon would say, maybe everyone should take his portion of effort and bring it home and then come back with something, and that would be an amazing result for this group. I should do that.
All right, thanks.
Link.
Hi, yes, this is Henk. Maybe I'm not off topic, but a different question, orthogonal. How's the chartering faring? I expected a lot of flurry on the charter repo, but there ain't.
No, the area director has taken the ball.
Okay.
He's trying to frame the thing and bring it to ISG for approval. We have a GitHub. We have a starting point on GitHub where we first did the draft charter that we presented in Madrid. Then some modification on top of that based on the feedback that we received during the BOF. But then the area director said, okay, let's well, there was some contention over a specific point, which was our idea of making the solution based on exported authenticators the solution that the working group would work on. And the area director said, let's frame this in a way that is less specific, to allow potential other people to come and present their own solutions that could be then taken into consideration by the working group, and then the working group would do the adoption call on a panel of different solutions. But for now, there's only one. So I think his intention was to present the working group as something that is more open than just a single point solution for a problem. We wanted to have at least initially some kind of debate around the design space.
I think it's more than that. It's not just more than one solution. It's actually we were trying to push for post-handshake attestation solution, and we got pushback on that as well. So it's not just that it's not our specific solution, but it's not tied to any of these parts of the design space. So it will be as open as it can be.
Yeah.
Okay. So there's no certainty on that part yet, but there is a trend. Okay. But the likelihood to have a formed working group meeting in November is given, right? Okay. Yeah.
That's what Paul said. That he told us that his intention was to get the working group rolling by November. So we have the first face-to-face meeting in there in Montreal. Yeah.
Thanks.
Cheers.
I wanted to question. Yeah.
Okay.
So yeah, I wanted to follow up on the discussion that was between Ariel and Greg. Maybe so from my perspective, I'm trying to understand that point a bit more. And I like the perspective that Ariel brought up, that is the provenance of the two keys. Like there are two keys. One is the long-term key, which is associated with Amazon.com as let's say the DNS name or the FQDN. And the other key, which is the key that is generated within the DE and is used. And I believe that's from my analysis that it shouldn't harm if I have to that kind of provenance from the long-term key that I'm sharing with all of the Amazon. That's might not be correct if I have that TEE, which is the one which is terminating the connection. So I'm using that TLS key from Amazon to ensure that I'm connecting to Amazon, but I'm not giving it over to all of Amazon. It's to the restricted trusted execution environment, which is ensured via the second key. So having two keys, I believe, takes care of the concern that was raised. Is that in line with your understanding, Greg and Ariel? Is it having two keys and then using these two keys, providing proof of possession of both keys, and one is related to or connected or bound to the ID, that is Amazon.com, other is within the TE, and it's ensuring that it's not going over to all of Amazon, but only to that specific trusted execution environment.
So I think that the two keys definitely have a separate role, but what I was wondering is that I don't think that with regard to like the long-term key for the domain, whether the second key, the attestation key, actually proves the property that the long-term key was only shared with enclaves. I think the issue is that like it proves that an enclave certainly has access to the private key, but it doesn't prove that that's the only thing that had access to the private key. So like, I'm wondering if there's any value in some kind of provenance for the generation of the long-term secret. Like you'd have some proof stapled to the leaf certificate that says it was generated, that the CSR, the certificate signing request, was generated inside of a TE. And then, you know, if you sort of had some visibility into what that code that issued the CSR was actually doing, maybe you could get some provenance about where that long-lived key ended up going.
I see. You're thinking more about attested CSR, attested certificate signing request, right?
Well, as not necessarily as a replacement for the second key that is used for remote attestation, but that maybe you're getting something slightly different in addition.
Yeah, I tend to agree with the two different responsibilities. Like, or they're proving two fairly distinct things, and they don't need to be bound together with the same types of evidence, because the things you're evidencing is very different. This is kind of what we did with our STEP protocol a while back. We used the exporting key material for an inner key exchange and had an outer key exchange that used the public internet TLS certificates, and that separation of responsibilities, made sense. That doesn't mean that they can't have attestation involved in the other layers too, but I think they shouldn't necessarily be bound to have exactly the same properties, because you're getting different things out of it. So I agree with what you were saying there.
Greg, and then we need to wrap up, unfortunately, because we're at the top of the hour.
I think folks are landing on basically what I was thinking of, and I think it's in my head. It's not just it's understanding that the entire key management. It's not just how it was initially created. It's like where the key management system allows it to go to, and maybe that's implicit after it's been generated in system X, that it's only allowed to go to like TEs of flavor Y. But that in my head is right. The party evaluating, if they really want to look deep, they want to understand, everywhere this key could have been and where it could go in the future.
Thanks very much, everyone, and thank you, Jonas, for the nice presentation. Everyone who participated in the conversation, yeah, I'll see you in a couple of weeks. And if the chairs could stay around a second to organize the next one, that would be awesome.
Thanks, everyone.
Thanks.
Cheers, guys.
Thank you. Bye.
I am going to be out for the next one. I am leaving on 2 weeks of vacation here soon. So.
Right. So Greg, Jim, anyone wants to take?
Yeah, let me check. What's today? 25th,
It's the 9th of September.
9th. Yeah, I can do it.
Fantastic. Thanks, Jim. Okay, I will.
Do we have topics lined up, or is that going to need to be arranged?
We do have one topic that is in the agenda, and there was this other thing from. Oh gosh, what was that? I don't remember. The thing about attestation layers. Mike was Mike's. So Mike has created a slide deck, and he wanted to I don't know, run a conversation on that. But we need to understand from him whether he is available next call or not. And
okay. Great.
Cool. Cheers.
Bye.
Sounds good.
Yep.
Bye.
Take care.